Hi everyone, this is part 2 of our discussion on stoichiometric calculations. The internet is down due to the weather, so we'll have to do this our old-fashioned way, okay? But the learning target is still the same. We have to perform stoichiometric calculations from balanced chemical equations, alright? Now here is another problem. Iron with a molar mass of 55.85 grams per mole reacts with oxygen gas with a molar mass of 32 grams per mole and forms rust, which has the chemical name iron 3 oxide. And you also see there the given molar mass. So the question is, how many moles of oxygen gas will react with 25 moles of iron? Alright, so a minute to look at the problem and internalize. What do you think is lacking in the problem? Okay, so there is a significant element lacking, and that is our balanced chemical equations. So let's use the whiteboard now. Okay, so it says in the problem that iron reacts with oxygen gas. So from that we can deduce that in one of the compounds in our balanced equation is iron. So let's just write Fe, and that's practically solid, iron nail, iron coating, okay? And then it reacts with oxygen gas plus O2, okay? To give us iron 3 oxide. What's the chemical formula of iron 3 oxide? That is Fe 2O3. Okay, that's basically our chemical formula for rust. So Fe2O3. Alright, now all we need to do now is to balance the equation. So take note that in balancing we have to make sure that the number of atoms both in the reactant side and in the product side are the same. So in the product side, I have 2 atoms of Fe, and therefore I can place the coefficient 2 beside iron in the reactant side. Alright, now however in the product side I have 3 oxygen atoms, and in the reactants I have 2. So what we can do is to swap, okay, or to interchange the numbers such that I'll be placing 3 here, so that I'll have 6 oxygen atoms, and I'll be placing 2 before the whole compound so that I will have 6 oxygen atoms. But if you've noticed, the number of iron atoms has been affected also. So to equalize the number of iron atoms, then we'll have to change the coefficient previously from 2, we make it into 4. Alright? Now we can see that there are 4 iron atoms both in the reactant and in the product side, and then 6 oxygen atoms in the reactants and in the product side. Alright, so now that we have our balanced chemical equation, what's the next thing that we'll have to do? Okay, so we are given 25 moles of iron, right? So let's just place it here, since this is a shorter way of doing it. 25 moles of iron, and then we are asked how many moles of oxygen will be reacting with those 25 moles. So let's start. So what we can do is have number of moles of oxygen, number of moles O2 is equal to what is given, 25 moles of Fe. Alright, so 25 moles of Fe, and then after that one, since we are given the moles of Fe and we just have to get the number of moles of O2, then what we can do is use directly the mole ratio. And we know from our balanced equation that 3 moles of O2 will react with 4 moles of Fe, right? 4 moles Fe. So in this, if we have this equation, then we can cancel out, okay? So I hope you know where 4 and 3 are coming from, okay? This is the mole ratio, MR, which comes from the coefficient of the balance equation. Now we can cancel moles of Fe, such that we will end up with moles of O2, alright? So what we can do now is carry out the calculation. So that's practically 25 times 3 divided by 4, right? And so we have 18.75 moles of O2. Since our given has two significant figures, then we can just end up with 19 moles of oxygen will react with 25 moles of iron. Alright? So this is the solution for part number 1 here. So I hope it's clear on your end. Okay, now let's go to the next problem. So if we try to, so we now have the balanced chemical equation. This time, number 2, we are asked how many moles of Fe2O3 is formed from 5 grams of Fe. Alright, so this time we have 5 grams of Fe, and we are asked how many moles. So number of moles of Fe2O3 from 5.00 grams of iron. Now take note that we are given the amount in grams of iron, so we have to cancel this one out using the molar mass. In the problem, the molar mass of iron is 55.85. So we place 55.85 below. So this is grams Fe, and then 1 mole of Fe. Alright, so in that manner we can cancel grams of Fe, cancel grams of iron. And then after that one, we now have the number of moles iron. We can use the mole ratio, okay, the mole ratio between iron and what is as Fe2O3. So in our balanced chemical equation, we now have the coefficients of iron and Fe2O3. So what we can do now is cancel Fe. So in order to cancel Fe, we know that there are 4 moles of iron, and then in the balanced chemical equation there are 2 moles of Fe2O3. Alright, so we can cancel this one out, cancel. So far our solution looks that way. We now have 2 moles of Fe2O3. So since we want to have the we want to have moles of Fe2O3, then we may stop until this part. Alright, so what we can do is perform now the calculation. That's basically 5 divided by 55.85 times 2 divided by 4. Alright, so again, that is 5 divided by 55.85 times 2 divided by 4. And then if you have it here, you end up with 0.04476 something. And then since you have 3 significant figures in your given, then it follows that your final answer must have 3 SFs also. So 0.0448. The preceding zeros are not significant. And this is moles of Fe2O3. Alright? There. So that's the whole solution for this item. I hope it will be clear. Let's try to get rid of the light. Okay, there.